Imagine just dropping a brand new employee into your company, right? Like pointing them to a complex multi-week project and then just walking away.
Yeah, you would literally never do that.
Exactly. You wouldn't. You'd want check-ins. You'd want to, see their thought process. And you definitely want to know they aren't going to accidentally delete the entire company database.
Right, which is a very real fear.
But yet, as of today, May 16th, 2026, developers are trying to do exactly this with AI. So welcome to the deep dive. Our mission today is to unpack a really massive source document detailing the current reality of agentic AI.
And we're looking at what happens when AI stops being this experimental toy that just writes polite emails and starts being a heavy-lifting autonomous agent.
Okay, let's unpack this because building a really cool AI agent demo for like a quick YouTube video, that's easy. It takes an afternoon.
Right.
But making that same agent reliable in a live production environment is a completely different beast.
Oh, absolutely. The novelty phase has genuinely ended. We are fully in the deployment phase now, and developers are just hitting a massive wall.
It's kind of like the difference between a concept car and a daily commuter, right? Like one looks amazing under the showroom lights, but the other actually has to survive potholes and, bad weather for a decade.
Yeah, that's a perfect way to look at it. And the first huge pothole developers hit, according to the text, is evaluation.
Right, because testing traditional software is wonderfully boring. You give a program an input, you check the output, it's deterministic.
Exactly. It does the same thing every time.
But agents are non-deterministic. The exact same prompt can produce wildly different sequences of actions just based on a slightly different network response or like a tiny variation in its conversation history.
What's fascinating here is that with traditional code, the path from A to B is basically a paved highway. But with an agent, you're dropping it into a dense forest with a compass.
Right.
It might take a different path through the trees every single time.
Yeah.
So as a developer, figuring out if that specific path was a good one, that requires a total paradigm shift in how we actually test software.
I look at it like testing a calculator versus testing an actual human employee. The calculator that gets 2 plus 2 right, or it fails. It's totally binary.
Yeah.
But the employee, they might use a calculator, they might count on their fingers, or they might just ask a coworker. They all arrive at the right answer eventually. But wait, if an agent's path is constantly shifting like that, how can a developer ever confidently say it actually works?
They literally can't without a new system. And that problem is why the source argues that a robust evaluation framework is basically the most crucial investment any AI team can make right now.
Okay, so how do they actually do that?
Well, the text breaks this down into 3 distinct pillars. The first one is task completion, which is just asking, did it succeed?
Did it get the job done?
Right. Sometimes this is binary, like dropping an agent into a repository and checking if the code it wrote actually compiles. But often it's way messier. It requires partial credit scoring.
Partial credit, like grading a high school essay.
Kind of, yeah. If the agent is writing a market research report, you have to grade it against a complex rubric for clarity, formatting, depth. Or you use reference comparisons, where you grade it against a human expert's gold standard work.
Okay, so that covers the destination. But I'd imagine the scariest part for a developer is the journey itself.
Oh, definitely.
Like if I tell an agent to find a specific client's phone number, it shouldn't download and read our entire massive corporate database just to find one 10-digit string. It should just run a targeted search query.
And that brings us directly to the second pillar, which is trajectory evaluation. It's not just about the destination, it's the journey. You're grading the agent's efficiency and logic step by step.
So tracking every little thing it does.
Exactly. How many steps did it take? Did it choose the right tools for the job? And critically, how well did it recover from an error?
Oh, right. Because APIs fail all the time.
Exactly. If an API endpoint fails, does the agent just crash? Or does it logically reason its way to a backup data source? You're basically evaluating its internal monologue to make sure its reasoning is logical.
And then there's the third pillar, which has to be safety and alignment. Because if you give an autonomous agent access to a company's tools, you have to know what happens when it, goes off script.
Safety is huge. The source mentions boundary testing. So if you give the agent an out-of-scope task like asking a customer service bot to issue a $10,000 refund, does it politely refuse?
It better refuse.
Right. You also have to test for prompt injection resistance, information leakage, and obviously hallucination detection.
Which is a major vulnerability. Like if a user hides a malicious command inside a PDF and the agent reads that PDF, You have to know the agent won't suddenly execute that hidden command.
Exactly. You don't want it forwarding sensitive internal data to some external server. And the tools to catch this are becoming really specialized.
Yeah, the source mentions a few specific benchmark suites.
Right, like SW Bench for code. It literally drops a coding agent into a real-world GitHub repository and asks it to solve actual documented software bugs.
Wow.
Yeah, and it tracks how many it can fix without breaking anything else. There's also Webarina for testing web navigation and GAIA for general assistance.
But the text also brings up a specific testing method that I really want to talk about because I have questions. LLM as judge.
Ah, yes. LLM as judge.
This is where developers use a separate language model to evaluate the output of their main agent. But hold on, having an LLM judge another LLM, isn't that just AI grading its own homework? Doesn't that introduce like built-in biases?
It absolutely introduces bias. Models suffer from self-preference bias, meaning they like their own style, and the source explicitly warns about this limitation.
Then why use it at all?
Because of the sheer scale of the problem. Human evaluation is the absolute gold standard, sure, but it's simply too slow and way too expensive to have a human review every single workflow iteration.
So it's a necessary evil.
Pretty much. Evaluation has to be a continuous pipeline. You automate execution, you score programmatically with deterministic code where you use LLM as judge for quick directional feedback, and you save the expensive human review for the subjective stuff.
That makes sense.
But you have to track metrics over time and aggressively avoid pitfalls, like only testing the happy paths or using static test sets where the agents just overfit and basically memorize the answers.
So they look brilliant in the lab, but completely fail in the real world.
Exactly.
Okay, so let's say you've successfully evaluated your agent. It passes all the tests, you want to release it. But the transition from a perfect local test to a deployed system brings this harsh reality of, well, money and time.
It's a huge shock for traditional software teams.
If evaluation is making sure the agent knows how to drive, production is realizing the agent only wants to drive a gas-guzzling limousine at 10 miles per hour everywhere it goes.
That is painfully accurate. The economics of agentic systems are just brutal because an agent doesn't just do one prompt and one response. It's a loop. It thinks, it calls a tool, it reads the result, it thinks again. That might require dozens of sequential LLM calls. And for every single call, you are paying to feed the entire conversation history plus massive tool descriptions back into the model.
It's eating thousands and thousands of tokens. If an agent loops 10 times, you're paying for all those tokens over and over again. Plus, the tool execution costs, paid APIs, infrastructure, it adds up incredibly fast.
Which is why developers have to aggressively optimize. The text lists a few major strategies, starting with model tiering.
Which is what, exactly?
It's basically routing. You don't use a massive, expensive model to do every single microtask. You route the really complex reasoning tasks to the large models. Like if you just need to format a date string, you route that to a smaller, much cheaper model. The source notes this can save 50 to 80% on costs.
That's massive. And they also mention context window management, right? Like constantly summarizing the history and truncating large outputs so you aren't dragging a massive file through every single step.
Right, and using caching, prompt optimization, and batching.
But even if you solve the cloud bills, agents are just slow. And latency is a huge problem. Waiting tens of seconds or minutes for a workflow feels entirely broken to a modern user.
It really does. Which is why developers use workarounds. Streaming responses is the easy one printing text to the screen word by word so the user feels like things are happening.
It masks the wait time.
Exactly. But the real technical solutions are things like parallel tool execution. If an agent needs to search 3 databases, it doesn't do them one by one. It fires all 3 simultaneously. Or they use pre-computation, like indexing data in advance.
But the coolest solution, I think, is speculative execution.
Oh, yeah. That's a game changer.
It's so cool. It's like, okay, if the system predicts that the agent will need a web search after it finishes analyzing a document, it literally starts the web search before the document analysis is even finished.
Right. It guesses the next move to save time.
And to support all this, the architecture has to scale.
Exactly. The source briefly details horizontal scaling. Basically, you use stateless workers that pull from external state databases. That way, if traffic spikes, you can use queue-based processing and auto-scaling to handle it, plus rate limiting, so one user doesn't hog all the resources.
Okay, so to actually implement all this tiering, the caching, the parallel execution, what tools are developers actually using? Because the source material outlines this massive six-layer modern developer stack.
It does, and it's a lot to take in.
I mean, I have to push back here a bit. With new tools dropping literally weekly, shouldn't a smart developer just wait on the sidelines until a clear winner emerges, rather than learning a tool that might be totally dead in a month?
It's a fair question. But if we connect this to the bigger picture, while the specific tools and brand names definitely change, the architectural patterns are completely stable.
Okay,
So if you understand the layers, swapping out a vendor later is easy. The text breaks it down into 6 layers. Layer 1 is foundation models. This is the ceiling of capability.
the brain of the operation.
Right. You have Claude, which has a 200K context window, making it great for code and long workflows. You have GPT-4 for broad capabilities, Gemini, which is natively multimodal, and then open source models like Llama and Mistral for when you need total control or specialization.
Got it. And layer 2.
Layer 2 is agent frameworks. This is the infrastructure. Things like LangGraph, Crew AI, Autogen, or even the Claude SDK, they hold the logic loops.
Then layer 3 is tools and integration, and the big thing here is the Model Context Protocol, or MCP. It's basically a standard adapter so agents can easily talk to APIs and data connectors without writing custom code for every single app.
Exactly, which speeds up deployment massively. Then layer 4 is memory and state. This is where vector DBs come in for RG retrieval augmented generation.
Wait, vector databases like Pinecone and Weaviate?
Right, Pinecone, Weaviate, Chroma, Qdrant, pgvector, plus traditional databases like PostgreSQL or Redis for speed, and even simple file-based memory.
And layer 5 is observability and evaluation, which we kind of touched on. Tracing tools like Langsmith, Arise Phoenix, and Braintrust. So you can see exactly where an agent messed up.
Right. And finally, layer 6 is deployment. We're talking Docker, Kubernetes, serverless setups like AWS Lambda, edge computing, and CI/CD pipelines.
That is a massive stack.
It is. And the key takeaway here is that the developer workflow has changed. Unlike traditional code where you write it, test it once, and ship it, agent development is entirely built around continuous evaluation and iteration because of that probabilistic nature we talked about.
Okay, so you have this perfectly optimized, perfectly evaluated six-layer agent stack. But here's where it gets really interesting. All of that brilliant engineering is completely worthless if a human being refuses to trust it.
Oh, 100%. Trust is the ultimate bottleneck.
I feel like trust is like a battery. It takes months to charge it up. But one highly confident hallucination from an AI drains it to absolute zero instantly.
That's a great analogy. And what's fascinating here is that the source frames ethics not as some abstract philosophy seminar, but as practical engineering. It's built into the system.
Right. They outline some core principles for this.
Yes, starting with transparency. Users must know they are talking to an AI. That's baseline.
Right.
And then there's accountability, meaning there have to be clear lines of responsibility when things inevitably go wrong.
And fairness, right. Strict attention to training data biases so you don't end up with disparate impacts in, like, loan approvals or hiring.
Exactly. Plus privacy data minimization and strict compliance with things like GDPR and CCPA. And finally, beneficence, which means the system should actually benefit society, not just optimize some narrow engagement metric.
So how do you practically build trust? And how do you accidentally destroy it?
Building trust requires reliability. The agent has to be honest about its limitations. It needs predictability and competence within its boundaries.
And it's destroyed by things like hallucinations or silent failures, right? Like when the agent fails a task but just doesn't bother telling the user.
Silent failures are the absolute worst for trust, along with overconfidence and inconsistency.
So engineering transparency in practice means building in explainable actions, giving human understandable rationales for why it did something, having detailed audit trails, and clear communication of uncertainty, like, I'm only 60% sure about this.
Right, and data provenance. The agent has to cite exactly where the search or the data came from so the human can verify it.
But this raises some huge societal impacts.
This raises an important question, yes, because we are talking about managing massive employment transitions. We're looking at a severe digital divide between companies that can afford these agent fleets and those that can't. There's the concentration of corporate power and obviously the threat to information integrity from AI-generated content flooding the internet at scale.
It was a lot to navigate. And ultimately, we have to preserve human agency so humans don't just become these passive recipients of whatever the AI decides.
Exactly. We have to stay in the loop.
Well, addressing these ethical and technical hurdles is exactly what unlocks the future.
Yeah.
If we look at the timeline from the source material, starting right now in 2026, the evolution is happening at breakneck speed.
It really is moving incredibly fast.
Today, in 2026, we know code agents write software and web agents can navigate apps. But they still struggle with long horizon tasks, things that span weeks, they lose context, and they're expensive. So where are we going?
The source maps out 3 future horizons. The short term, between 2026 and 2027, focuses on smarter model routing, dynamically matching tasks to the exact right model to save costs.
Okay.
And we'll see persistent, long-running agents, agents that maintain state across sessions, tracking complex projects over months without forgetting everything. Also, tool discovery is going to shift to those MCP registries, acting as dynamic marketplaces for agents to find tools.
Okay, so that's next year. What about the medium term, like 2027 to 2029?
That's where we get agents that actually learn from their interactions to improve without manual prompting. We're going to see multi-agent ecosystems.
Like agents talking to agents.
Exactly. Your personal agent might basically hire specialist agents, a legal agent, a graphic design agent, and manage them.
Wow.
We'll also see embodied agents, so robotics entering the physical world, and agents driving massive scientific discovery by handling ruling computational workloads, while the humans focus on the actual intuition.
Which brings us to the long term.
Yeah.
2029 and beyond. The source points toward general-purpose autonomous agents capable of literally any intellectual human knowledge work.
Yes.
And agent-native applications, software built specifically for AI to operate, not humans. No buttons, no screens, just pure API interaction.
But I want to conclude this section by highlighting the source's ultimate takeaway because it's important. The future isn't AI replacing humans.
Right.
It's a partnership. Humans bring ethical judgment, physical world experience, and actual creativity. Agents bring perfect recall, vast information processing, and just tireless attention. That ultimate partnership is what this is all building toward.
We have covered an immense amount of ground today. We started in the absolute nightmares of testing non-deterministic workflows. We dug into balancing the cloud bills, the 6-layer developer stack, the rigorous engineering of human trust, and this wild timeline leading to general-purpose agents by 2029.
It's a lot to process, for sure.
It is. But I want to leave you, the listener, with a final thought to mull over. Something building on that idea of the human-agent partnership. If by 2029 you have an agent that perfectly complements you, an agent that knows your exact weaknesses and constantly covers your blind spots before you even have to ask, what happens to your own skills?
That's a heavy question.
In a world of perfect AI partners, do our human capabilities slowly atrophy because we never have to struggle or learn the hard way? Or do they evolve into something completely new? Thank you so much for joining us on this deep dive. We'll catch you next time.